Welcome to the Explainer. Okay, today we're going to entirely strip away all that wild internet mythology surrounding the idea of free energy. We're replacing it with real, measurable science that you can literally test in your own backyard. We're just bypassing all the rumors and diving straight into the actual chemistry and physics of ambient energy.
So let's just dive right in by fundamentally changing how we look at the world around us. We usually think of the ground as just, dirt, right? Just dead matter we walk on. But the environment around you is actually a living, active electrical system. Just like the quote says, every handful of damp soil is a tiny battery waiting to be completed. It's a chemical framework that's constantly buzzing with ions, moisture, and minerals.
Which brings us to a massive question. Can you actually pull usable voltage from the earth beneath your feet and the air above your head, and do it without spending a fortune? Well, today, we're going to explore two weekend projects that absolutely prove you can generate low-power voltage using basic hardware store parts and just the forces of nature. And the best part? It's all for well under $40.
So here's our roadmap for today. First, we'll explore the hidden electrical grid. Then, we'll build a $9 earth battery, tap the sky's voltage, uncover the secret in the soil, and finally, we'll look at powering your curiosity. Let's trace this incredible journey from the dirt all the way up to the sky.
Part 1, the hidden electrical grid. We're reimagining the environment. Simply put, the dirt in your backyard is basically a massive, naturally occurring battery asset. Part 2, the $9 earth battery, tapping into the ground. Let's actually build our first project, which is a 16-cell earth battery.
Now, what's genuinely incredible about this setup is that it uses practically zero commercial tech. All you need is some half-inch scrap copper pipe, a few galvanized landscape spikes, and some standard copper wire. You can literally build a working power source for $9.40. That is less than the cost of a coffee and a sandwich these days, and honestly, a whole lot more electrifying.
And just to be super clear here, this isn't some trendy new internet life hack. We're talking about established science dating way back to Alessandro Volta in the year 1800. By the 1840s, earth batteries were actually powering telegraphs, and by 1914, soldiers were improvising these exact same systems in the muddy trenches of World War I whenever their conventional batteries died. The underlying principle never stopped working, it just kind of quietly disappeared once commercial batteries got cheap.
So, to understand exactly how your backyard dirt generates power, we need to talk about the galvanic reaction. This is exactly what happens when two different metals get placed into a conductive medium. For our build, we use the heavy zinc coating on our steel rods and the lighter copper pipe. The zinc slowly oxidizes, which releases electrons that flow right through our wire directly to the copper. You can think of it exactly like a seesaw with two kids of different weights. The heavier kid, which is our zinc, always pushes down, which in turn pushes the lighter kid, the copper, up. And that movement between them, well, that's your electricity. But here is the absolutely crucial key. Without the moist soil acting as the fulcrum right in the middle, those metals are just going to sit there doing nothing. But together, they create a very measurable 0.7 to 0.9 volts per cell.
Now, construction is where most people actually fail, so here is how you build it right. First up is spacing. You have to keep the cells 12 to 18 inches apart so they don't steal current from one another. Second is depth. You want to push the metals 4 inches into the soil. And finally, the connection. You must lightly sand the metals and then wrap the wire super tightly. If you don't, those invisible oxidation layers act as insulators, and they will completely block your current. No way around it.
Moving on to part 3, tapping the sky's voltage. This is Tesla's 1899 atmospheric generator. Escalating our ambition here, we're going to leave the Earth and look up. We are exploring Nikola Tesla's widely misunderstood 1899 patent for capturing electrical energy directly from the atmosphere. And instead of getting totally lost in all those wild myths, we're looking at his actual, publicly available laboratory notes. The physics is surprisingly straightforward, and believe it or not, you can rebuild a working version for exactly $31. By just using basic, readily available hardware store parts, we can string up a 20-foot aluminum wire to act as a vertical antenna. Then, we use a really simple bank of electrolytic capacitors to store the charge, standard silicon diodes to convert that to direct current, and a copper ground rod. With just this simple array, we can physically capture the electrical potential of the atmosphere itself. The physics driving all of this rely on what's called the fair weather voltage gradient. This was discovered well over a century ago. Basically, the atmosphere carries a natural electrical potential that actually increases by roughly 100 volts for every single meter of altitude you go up. This isn't sci-fi stuff. It's a very real phenomenon that is continuously measured by meteorologists all over the globe.
But crucially, we are absolutely not creating free energy out of nothing. See, the Earth carries a negative charge, and the upper atmosphere carries a positive one, basically acting like a massive planetary capacitor. We're simply collecting the charge that is constantly being replenished by global lightning, which, by the way, strikes about 100 times per second worldwide. We're literally just catching energy that's already falling, exactly like a giant rain barrel catching water.
All right, part 4, the secret in the soil, the single point of failure. So, despite the highly documented science behind both of these setups, there's a singular variable that connects them both, and it's the exact reason why so many DIY weekend attempts just completely fail. So where do most people ruin the experiment before their multimeter even comes out of the toolbox?
Well, the big secret is ground conductivity. If you test a ground rod in dry, sandy soil, it will totally ruin your setup. It creates incredibly high electrical resistance, resulting in maybe 0.3 volts. But if you test it in heavy clay or moist soil right after a rainstorm, it drops that resistance by an order of magnitude. This completely unlocks the system's power, shooting your output all the way up to 3 to 6 volts. So moist soil is entirely non-negotiable for sure.
You don't even really need a multimeter to test this. Just push your finger 2 inches into the earth. It should feel cool and damp, exactly like a wrung-out sponge. And amazingly, after an hour or so of atmospheric collection on a humid day, that copper ground rod will actually feel faintly warmer than the surrounding earth. That slight warmth, that is literal atmospheric current dissipating right through the soil.
Which leads us to part 5, powering your curiosity and setting some real expectations. Now, before you go digging up your whole yard or climbing up onto your roof, let's just ground this in reality for a second. These systems output microamps and milliamps. That's a tiny, tiny fraction of what a standard wall outlet provides. They're brilliant for slowly accumulating a charge over 12 hours, maybe running a small fan or trickling power into a phone. But they are absolutely not going to replace your home's electrical panel or run a refrigerator. This is ambient trickle energy we're talking about, not a diesel generator.
But, the magic isn't really in powering a refrigerator. It's in realizing where the power actually comes from. I mean, even a $2 dirt battery that just lights up a single LED is enough to change your perspective forever. You are literally capturing ambient energy from the air and the dirt right around you. So I guess the only question left is, when are you going to grab some scrap metal, step outside, and prove to yourself that the natural world is electric?